looks like we're back to Isaac Tiemann's at number 7 as I save the screen here. What will the universe end in a big bang? Will the universe end in a big rip as phantom energy pushes the acceleration of universal expansion past the speed of light and all distances between points converge to infinity? Well, that's one possibility, Isaac, and obviously that depends on the amount of a total amount of mass in the universe. Funny question, obviously, but there's a serious answer to that. The question about the future of the universe, the big future, is pretty simple, and that is there enough gravity? Certainly the universe is expanding. There's no question about that. We know it's expanding. We know the rate of its expansion. And if we run the clock backward, we come back to the Big Bang and Planck time and all the rest. An infinitely small, infinitely dense, infinitely hot point that has been expanding at a rate that we're able to compute with a very high degree of accuracy. And furthermore, we see background radiation, background radio signals as a result of that initial explosion. They're out there, they're where they're supposed to be, they're at the right frequency, they're at the right distance, all of that. So where does it go in the future? Well, if you've got this gigantic explosion that's pushing the universe apart, and the universe is composed of matter, and matter has gravitational effects on each other, every instant that it expands, the gravity of all of the universe is going to want to pull this thing back together again. So the question really is, did the Big Bang have escape velocity? I think that's not a bad way to put it. I've never heard it put that way, but it's not a bad way to put it. Did the Big Bang achieve escape velocity? Escape velocity means when you get something moving fast enough on the surface of a planet like the Earth, if it moves fast enough, it's not only going to go into orbit. Well, technically you need a circularizing boost, but if you've got something that's moving fast enough, it will escape the Earth's gravitational pull. It doesn't matter how much. Once it hits a certain velocity, the gravity of the Earth cannot stop it anymore. It's got escape velocity. It's leaving the Earth's gravitational field. It's not leaving the sun's gravitational field, but it's leaving the Earth's gravitational field permanently. It's out of here. Escape velocity. And so the question is, did the universe's initial expansion achieve escape velocity? Did the universe expand energetically enough so that even though the mutual attraction of matter wants to pull it back, slow it, stop it, and reverse it, is it moving fast enough? And really the question is there enough matter to stop it? Because if there isn't enough matter to stop it, then what you just suggested happens. The universe just essentially runs away and just gets bigger and bigger and essentially just cools to nothingness. But if there is enough mass, then it stops the acceleration, and then it's returns to start shrinking, and then eventually collapses back into that point again, which would be a sight to see, I think. And I think the latest answer, according to what we know of science, I believe the latest answer is yes, there is in fact enough mass to stop this expansion. We're seeing the universe expanding at a rate that indicates that it's slowing and will in fact stop and reverse itself. That's the good news. The bad news is that even though the mass is there, we don't know where it is. We can't find it. It's not visible mass. It's not stars. It's not nebulae. It's not dust clouds that we can see. It's not even the presence of dwarf planets or brown stars and that kind of thing. There seems to be enough mass to be stopping this expansion, cause a creation of it, and a large amount of that mass is not visible to us. We don't know what it is, and we don't know where it is. It's the famous dark matter, there it goes. Let's see if our gifted actual says escape velocity is still in orbit. It's not in orbit. Escape velocity, the definition of escape velocity is you've escaped orbit. In any event, that's the question and the answer, and this is an eclectic show, so there we go.